So next steps, I guess, is, like I said, first steps are understand where your data came from, and then limitations of it, and also how to leverage it. That's kind of what a part of this as well is. We got all this great data. Some of the sources I kind of tossed up here, I'm sure most of you are aware of. Many of these is, some of the big ones now is, say, open data from municipalities. This is one of the huge pushes for data, is to make whatever spatial data, non-spatial data available for free to the public. So we use a lot of open data. There's some great open data sets on City of Edmonton, Strathcona County, fantastic data sets that are available for free. GIS, I know every municipality, every company basically has some sort of data in a GIS environment. Google, of course, everybody uses Google when they can. OpenStreetMap's another great one. We can actually they got street networks for the entire world. Everything's free. It's all mapping great, but it's all available. They've even got building footprints. They got addressing. They've got a whole bunch of information. Then we get into, say, the different types of LiDAR. So we got aerial, terrestrial, ground. We've got UAVs, aerial imagery, satellite imagery, photogrammetry. So all of this data together is just sources of information from somewhere, all various accuracies, all different types and formats. So basically, and then in the middle is other data that you just kind of appears in your lap from somewhere. So how do we kind of work with this information? We'll kind of walk through a little bit more of the LiDAR side, because again, I think most of you have probably seen maybe an image or a data set like this. This is just a color-shaded model from LiDAR of just a ground surface. So we actually use this a lot within our company, from planning, engineering, surveying, etc. Actually, even from, Jim's here from Parks at the city, and we've actually used it for a bunch of top-of-bank extraction. So we're actually using it for a lot of different types of extraction in the office. It's kind of a process and art and how you have to work with it, but we can do quite a bit with it. The big thing is that most people just get this, or they don't even get this. They might just get a contour plan. So kind of going back to some of the raw data is really where it's some of the importance of figuring out what you can do with this. If you actually look at more of a full feature data set, so this is kind of an image file of a LiDAR data set. So it actually includes vegetation. So that's how you can actually see that where all the dense canopy is down in kind of a ravine. You can make out kind of a little tree line here. You can make out some buildings. There's some small buildings kind of inside here. So again, it just takes everything, including terrain, and puts it into a surface. So very valuable for tracing extensive tree lines, extensive vegetation. Since that might be kind of hard to see, but since LiDAR also comes with a reflectance value, it's, dark colors reflect less, white colors will reflect more. You can actually get in to start doing some other analysis based on reflectance. Next steps to it is there's classification routines that can be run on this LiDAR data, as well as to basically layer or organize a point cloud. So you can run all kinds of automation on it. So you take all the raw data, runs it through a bunch of filters, and it'll actually classify ground, what's low vegetation, medium vegetation, high vegetation, what it detects as buildings. You can do power line extraction, and all these things are quite automated in some of the better software that is out there. So a lot of the data we get is just kind of classified into ground and non-ground. So we take it and reprocess it, and we can actually do more with it. So you see in here, all the brown is what's considered ground. The darker green there is kind of the low sparse vegetation. The taller green is kind of higher vegetation. Other steps you can do is actually color the point cloud, similar to how we did the terrestrial. You can take an aerial image and color a point cloud with it. So it looks a little bit more realistic when you start looking at it in this side. You can start making out crop and trees and buildings a little bit better. Then you kind of get into more of a dense urban environment with LiDAR. So all of the raw data as well is, you can kind of, might be hard to see, but all the red data, you can see the 3D buildings. So this is fully automated, this software, how it did it. Read all the raw aerial LiDAR data, can actually extract vegetation, extract buildings, building footprints. You can actually get rooftops, and I guess extensive building sizes all off of just the raw data. Then we also have open data, which I'm assuming a number of you are from City of Edmonton, but zoning data, I guess, was made free here a while back. Building footprint data set, which was all actually extracted from a company in the States to extract every building footprint. Good to within about a foot to a half meter. Great data that we can actually use for a bunch of visualization. A tree data set. In my mind, that's fantastic. It's got rough location of a tree and a type and a size. So we can actually take those and turn that into a three-dimensional object. Strathcona County kind of even one-upped it a little bit. They've actually got building footprints with heights. That's one of the best features to actually have as well, is now you actually can start building a little bit more realistic geometry, because you've got a footprint and a height associated with it. So we can take giant data sets and build a 3D environment out of it. Aerial imagery is also something Strathcona County made free. So I'm not sure, just a little plug against the City of Edmonton, that a lot of I guess municipalities, cities are making more data available for free. I know it's kind of a different business model, but it's something I guess that people are getting a lot more of now. City of Toronto also did it again one step up, as they actually had a company create 3D buildings. So you can, instead of just doing a footprint with a height, it now actually does a 3D building with facades. You can actually get parapets on the tops of the buildings, little vent shafts on the top of the buildings, all done from aerial imagery. So pretty inexpensive, kind of the grand scheme of things and what you can get out of it, but very interesting data that's kind of usable in more of a planning environment, especially as we get into a lot of infill redevelopment, that kind of thing. So this is kind of where we're going to get into a little bit more of kind of the procedural modeling, or what we actually do with some of this data. Maybe a show of hands first off. Has anybody heard of Esri City Engine or used it? Is anybody actually using it? Okay. Our Autodesk, I guess, has one called InfraWorks. A little bit different, but City Engine's kind of one of the bigger ones. We've been using it for a couple of years now. It's good and bad. It's, I don't know, I've got another slide on it being kind of SimCity-ish if you've seen it, but it's got some very good ways of taking inexpensive data and making something 3D out of it. So again, it starts with data from any source. Procedural is basically rule-based modeling. So you take computer rules that'll apply something to a data set, and you can turn it into something three-dimensional. So all these rules can be custom programmed. There's people that can do them. A lot of the software comes with free rules that come right out of the box. But the best part about it is you can actually do dynamic modeling in real time. So everything you design in this environment is in 3 dimensions in real time. So again, City Engine InfraWorks. So a little, not going to get into much about the programming side of it, just kind of give a bit of an idea of what you can do with it. So this is kind of a simple extrusion command. So in the background you can see this is just a parcel data set. So the rule is basically it's going to take the lot, it knows it's a lot, it's going to extrude it, it's going to randomly put building heights in from a minimum height to a maximum height that you can specify as part of a rule, and it's going to create a building envelope. So very simple line of code, but basically with this data set you can select thousands of polygons you've got in this GIS data set, and it'll automatically extrude shapes to different heights. You can also read attribute data from GIS, so if you had a data set with footprints and heights, you can read that data set, apply the rule, and it'll actually recreate buildings within a box look, but it'll actually recreate a building based on a rule. There's extensions to that of what else you can do with it, and that's what I'll show you in some of the other examples. So again, kind of how does it work? So it starts with just simple geometry. So the grade that you see is actually just, say, a street center line, which City of Edmonton's got a street center line. OpenStreetMaps has a street center line. So you can read the data. Once it creates a closed shape, it actually detects now that it's a closed parcel, and it'll actually create another kind of little intern blue line. So it's going to start subdividing parcels as soon as they're interconnected. Next step is we actually want to tell the center lines that it's actually a road. So this is just as simple as by dragging a rule onto that object, and it turns it into a road. Doesn't look like much yet. But once it does this closed shape again, now you've got some of these rule-based parameters. This is the rule for the block. So basically it's taking that shape, and you can tell it true or false, basically, whether or not you want to subdivide that shape automatically. So you can put in a bunch of rules for minimum lot width, area size, that kind of thing. So if you know, again, this is where it's not perfect. There's always going to be, it's going to generate some sort of geometry. But basically now by setting a few parameters, you now actually have a bunch of dynamic parcels created just by doing a couple sliders in a program. Next steps is actually applying other rules. There's a street construction rule, there's a green space rule, there's a building construction rule. So all of these have a bunch of parameters to them. So you basically drag and drop it. So drag a street construction to a road. Now, just by dragging and dropping, it looks like a road. So it's set based on a width. It's got a set number of lanes, it's got a sidewalk. You can actually customize that as well to put in people, cars, number of lanes, driving lanes, and it's just a matter of kind of changing a slide bar within a rule. So everything's very dynamic and updates in real time. From the parceling side, we can actually add, say, like a building geometry rule. So this is actually going to just, again, drag a rule to a parcel, and now it's going to start generating some sort of geometry based on the defaults for the rule. So it's going to create this U-shaped building, bunch of kind of landscaping trees and people in the middle. It's just all defaults of how the rule is based. But the nice thing about it is that it's highly customizable after the fact. Like, it looks a little overwhelming, but this is actually just all slider bars or entry bars for things you actually want to enter in there. So we've got things like Traffic direction, so of course, I don't know, it's kind of the company's overseas, so it's built to drive on the left side of the road instead of the right. Lane width, lane size, whether or not you want a median, whether you want grass in the median, whether you want trees in the median, do you want them spaced every 10 meters in the median, do you want to add sidewalks, bike lanes, all that kind of thing. All just a matter of kind of changing parameters in the rules. For the buildings, again, you can actually get it to randomly add textures. So to kind of make it more like Google Earth-ish, to kind of actually randomly add textures to buildings. Instead of just looking at kind of a massing model, it'll randomly apply building facades to buildings. So it kind of adds that next level of realism without putting a lot of effort into it. So again, just by changing a couple of parameters in the rule, I can now change the building, say structure on one side, but we can do this with zoning footprints, because you can actually have setback information as part of the rule. And respace trees, kind of move pathways, all that kind of thing. If you don't like it, change it, put another building in. And this is, again, just by changing a couple settings within the rule. Detail of it is really as advanced as you want it to be. This is kind of a zoom in on that, see on that building rule. So right now, it's actually got rules for height of building, height of eave, the parapet height, whether or not you want eaves, the type of window. So just by changing a couple parameters in that as well, you can now make it with a different type of roof, different type of window, different type of sill, and basically no overhang for the eaves. So highly customizable rules. And really, it's as much as you want to customize them, as much detail as you can get into these rules. So there's a couple things about it. But so I guess benefits of it, multiple design iterations. That's kind of the big thing on it, because it is like SimCity, where as you're drawing things, you're changing things, adding rules, changing street widths. Everything's fast and everything's connected. That's kind of one of the nice things about it, is parcels are connected to roads, roads are connected to the buildings are connected to parcels, and the reporting is connected to the buildings. So in the example on the bottom there, you kind of see, you grab the node for the intersection, you drag that intersection, the parcels move, they re-subdivide, buildings re-subdivide, everything rechanges on the fly. So that's, again, one of the nice benefits of this is kind of a planning tool, is to be able to physically move things around with very little effort. Kind of going to jump into a bit of a kind of the visualization side of things here. World's not 2D, I guess. My side of things is I don't like designs being two-dimensional. I can't stand 2D information. I guess my background is as a surveyor, and I kind of got out of that. But there's a lot more three-dimensional design because the tools are becoming a lot easier to work with now. So there's a couple things that we've done on some projects is basically you can, again, this is a city engine scene that we did. We started with a conceptual plan, traced a bunch of roads, traced a bunch of buildings, added some vegetation, and in about 10 minutes you can actually get this three-dimensional scene up and running in a web browser. So everything is highly customizable. You can actually have options to how you want to visualize things, but very simple to generate something like this on the fly. 3D zoning volumes. This is one of the really nice things as well, is where you can start coloring zoning. So assigning heights and actually visualizing a zoning volume in 3 dimensions. So it kind of, again, adds, instead of taking whatever 15 pages of a zoning interpretation and turning it into something 3-dimensional, it's very easy to understand this in a 3D environment. I've got a live demo of this as well, but redevelopment before and after, this is one of the big applications that we see for, is the fact you can have this running in a web browser with various versions of what you want to view. Just by dragging a little sidebar, you can actually see your before and after in a web interface. Shadow analysis is one of the other big things. Again, we can send this and give it to anybody. They can run, there's a kind of sunlight information in the corner. You can change the day, change the time. And you can run shadow analysis, right, again, off of very inexpensive data that might be open or free to you to use anyways. Zoning comparisons, another example one. This is just one I grabbed off the website, but it's basically another way to visualize different zoning types. As you zoom in, you can actually have different classifications, and you can view them differently. So they've got a buildings view that's on the left. They've got a 3D zoning view that's on the right. And they also have, a stormwater infiltration analysis. But again, in a comparative window, you can have different views, drag the slide bar, everything will change kind of dynamically. We did a project in California for line of sight. We bought a bunch of buildings from a third party. So they basically can generate 3-dimensional buildings that can do about a foot. You can get about, I think it's about a square kilometer of buildings created for about $3,000. So which is fantastic for that accuracy of data. We don't have to do anything, and that's where you get building roofs. You get parapets on roofs. You get little vent shafts and everything. So they were actually looking at doing a proposed cell tower location. So I actually wanted to see where in the city you could actually, see that tower. So again, working with if you had open data, you could use it. but we wanted to get a little bit of better data set to actually work with better information to do the analysis a little bit more accurately. You can see you can take giant areas. You can take city-side data sets into software like City Engine and visualize everything in 3 dimensions on a city scale. Print everything, just the same data. Downtown visualization. Again, this is another project in San Francisco we were working on, so we bought a bunch of information from it. You can kind of see the detail in the buildings there for all the vent shafts on the top of the roofs. We can't manually model this data for $3,000 for a square kilometer of buildings in any urban environment. Like the data, these companies just strive off of working, creating this data very effectively. So this is kind of an extension of some of the building footprint data that the city of Edmonton Strathcona has actually purchased. Is they've only taken the first step of it and bought the footprint. Next steps are to take an actual building model, and there's various levels of detail that they can actually build these building models for. So I'm all for having more data in these 3D buildings. There is a cost, but again, in the long term, it's great data that we want to actually utilize for a bunch of work that we do. I got a bunch of live demo stuff. The kind of last thing is kind of jumping into ways that we can maybe view some of these things. I don't know if anybody's heard of Oculus Rifts. Facebook bought them a while ago, paid billions of dollars for this company. It's got these head tracking headsets. You put the set of goggles on, inside of it's actually a stereo view. The nice thing about, say, City Engine or any of these 3D design packages, you can actually take that, throw it into a video game engine, and actually run it on an Oculus headset. So you can put this headset on and look around. I've got the poor man's version of it if anybody wants to try afterwards. It's a little bit different, which is basically Google Cardboard. This is a different brand, where you actually put your smartphone in the front, and you can actually run a stereoscopic 3-dimensional view on cardboard glasses. So it's just got a couple little viewfinders inside, and as you pan and move your head around, you can actually visualize yourself inside of an environment. So all of this stuff is becoming a lot more prevalent. Microsoft HoloLens is another big one that's just kind of coming out as well. It's even a little bit more interactive, where you can put the set of glasses on and start interacting with the environment. Fantastic tools for interacting with your design, other types of workflow. A little bit out there, but again, this stuff is becoming very easy to do, especially designing in 3D anyways. You're already 90% of the way there. Now you just have to take it the next step to kind of turn it into a little bit more of a video game environment. So yeah, Google Cardboard. Other steps we're kind of looking at as well is this kind of more of a hologram room. It's kind of a little bit more of an immersive environment. We can actually set up a room of whatever size you want. It's got multiple projectors to actually broadcast on different faces. So you can take any type of 3-dimensional data and broadcast this inside of a room and virtually walk inside of a room, inside of the hologram room, just wearing 3D glasses. It's kind of an eerie feeling. I was at a conference a while ago where they had it on a roller coaster. I know you're standing there trying to go on this roller coaster as it's going through the track. It's a little weird, but again, just another interactive visualization that people can relate to kind of things in 3D a little bit better.